Hello, everyone. I welcome all of you in our today's session of Trust Electric Vehicle Awareness Oath Empowering Youth Phase Second. Today, we are having our international webinar on designing electric bus powertrain with our expert, Mr. Adil Irshad. The sessions are being organized by Teachers Training Center and Learning and Resource Department of Technical Education, Jodhpur. So, like talking about the Trust EV Awareness Auth program a bit. What is it about? It's basically a free education program on electric vehicle initiated by me as an individual. I am an electrical engineer in the electricity department of Rajasthan State, India. So the reason behind starting this free awareness program is to promote the adoption of electric vehicle and help India achieve its dream of India 30 at 30. That is having 30% of electric vehicle on the roads by 2030. Also, it is helping Rajasthan EV policy 2022 that also incorporates mass adoption of electric vehicle. This is to help young engineers and especially women to adopt the skills of electric vehicle industry. How does it work? It works in offline mode, in online mode, and hybrid mode wherever it is possible. I go from state to state, places to places, and teach students, youth like you, electric vehicle. And to know more about electric vehicle problem, the basic problem in the mass adoption of electric vehicle is an awareness. As I've already mentioned, the program promotes the awareness in electric vehicle. Second thing is that the technical education is lacking in today's youth, which can actually facilitate the mass adoption of electric vehicle by improving their efficiency and reducing their price. So Trust Electric Vehicle program is about educating all the youth for free in technical side and in non-technical side. We take non-technical youth and make them aware about the benefits of EV, financial and environmental. Then we take up technical youth of our country that belongs to technology and the technical departments or uh, any sort of technical mindset that links them to engineering, and we teach them the whole electric vehicle technology as it is. So they are taught in three phases majorly, that is phase one, phase two, and phase three. Phase one is all about the ecosystem of electric vehicle. For example, how the electricity is generated for the electric vehicle to be charged, how it reaches to the charger, what kind of charger do we use, what kind of connectors are there, what is the slow and fast charging process, what are the modes of charging, what are the levels of charging, which country is using which type of connector gun, what are the types of pins in the connector gun. Then we talk about what is the whole system supported by, that is the incentive and schemes of the government. So we talk about these schemes and incentives, that is the discount provided by government through a live example of setting up an electric vehicle charging station. So there we see that how do we actually set up an electric vehicle charging station? What kind of chargers do we use to have it in India, a public charging station? What kind of other methods do we have? For example, battery swapping stations, how the land authorities and the implementation agencies, electricity agencies, how all of them are involved and what are their rules and regulations that we have to follow if we have to set up a charging station. This gives the youth not only the technical mindset and foundation, this also develops along with that the business side and their policies and knowledge. After that, we also learn about the communication in electric vehicle ecosystem. For example, a CAN system, control area network system, is used to communicate with EV and EVSE, the electric vehicle supply equipment. EVSE in turn communicate with central management system and e-mobility service provider app using OCPP, Open Charge Protocol. So we study all these things in phase one and develop a strong foundation of electric vehicle. After that, we have developed the foundation, we move on to phase second. In this phase, we learn about the interior of the vehicle, how a vehicle is actually constructed, designed. We do not talk about anything else apart from vehicle now. So we have about all knowledge about all the types of vehicle, that is plug-in hybrid, hybrid electric vehicle, fuel cell electric vehicle, battery electric vehicle. Then we go on to the working of the electric vehicle in particular. Then we narrow it down further to each component, that is controller, battery. Then we learn about the motor, and so on and so forth. We also learn about the wiring connection of whole equipment, whole devices that are used in the electric vehicle. We learn about the powertrain design of electric vehicle. How do we actually find the rating? How do we calculate how to find the rating? Everything in that. So, with this knowledge, our youth is developing a strong mindset and their belief system in electric vehicle. This is completely free education. The reason is that the education in electric vehicle, especially the technical, is very costly, which is keeping our youth not to excel themselves in electric vehicle, and hence they cannot improve electric vehicle. I firmly believe that every individual has their unique talents which can be used in electric vehicle industry to uplift it, to improve it, to make it more efficient. And that is why I am providing free education to all the youth. This is not supported by any NGO or a company or any foundation. This is my own startup as a human being to save the only home planet that we have, the blue dot. If you want to invite us to your organization, college, institution, or any place that you work at or study at to have these free educational lectures, you can contact me at trustev.nehasakka@gmail.com, or you can simply Google Trust EV Nehasakka and you can contact me via that. So, in this today's lecture, the Trust EV Awareness Oath Phase Second, we have our expert lecture from Mr. Adil Irshad. I would like to define him by his ideology or in one statement that we can never relax when it comes to protecting our planet. Mr. Adil Irshad is a Chief Operating Officer in EV Technology at Sir International Investment Group. He is an entrepreneur born and raised in Oman and United Arab Emirates. He studied in the US and enriches sustainability, transformation with innovation, environmental, social, and governance initiatives, and climate change adoption. He has firm determination, passion, focus, and vision for a better world towards net zero emission, e-mobility for an improved and healthier significance of our green, sustainable environment, a better tomorrow for us all. He has turned his passion of finding the transformational sustainable technology into a career. Sir International Investment Group, through his insight, advisory, and vision as Chief Operating Officer in EV technology, has achieved innovative goals and electrification success of transforming an oil and gas based business group into a sustainable, promising business model for electric vehicles. Today, EV technology as IIG is reaching the Middle East and North Africa region as a pioneer in pure electric vehicle brands business. The salient feature of SIIG are their singular focus, clear goal, and motto of only dealing with the new energy brands of electric vehicle manufacturers. I am delighted to welcome such an expert amongst us, Mr. Adil Irshad. In his words, innovating is about being in love with the problem, developing the flawed ideas. Change is not easy, but as per the climate change scenarios, we need adaptability towards all form of net zero emissions. We can never relax when it comes to protecting our planet because the climate change doesn't let us either. I welcome you, sir. Over to you, sir.
Thank you so much, Mrs. Neha, for this opportunity. And good evening, namaste, assalamu alaikum to everybody who's listening to me. My name is Adil Irshad. I'm from EV Technology, Sur International Investment Group, as the Chief Operating Officer for the group. And it is my immense pleasure to speak and talk to you about today's topic, which is designing electric bus powertrain. Having said that, I would also let you know in the beginning of this entire lecture that these uh, all slides and thoughts are based on my research, my personal thoughts, or has been taken in context from a lot of research departments. Plus, there are a lot of people who will be watching could not I mean, a lot of people who are watching could differ from my opinion, could differ from my research, but this is purely based on my research. So opinions and critics are welcome, and opinions can matter and different from each other. Having said that, I would start my lecture today, and please uh, post any questions that you may like in any language that you may like. So Neha can post the questions to me, and I can easily reply you. In other way, if there is more I could do to assess those questions, you can ask Ms. Neha to email me, and I could elaborate to you. I have no problem. I'm here for education and awareness and youth empowerment. So I love you guys, and I expect the same love for my work and for me. Okay, so let's do this. Uh, so first of all, thank you to Teachers Training Center, Learning Resource Department Center, Department of Technical Education, Government of Rajasthan, India, and special thanks to Neha for organizing this free of cost educational event. Uh, as Neha has spoken to you a bit about me, so I think I don't need to mention this. I call myself an entrepreneur because I think there is no planet B. There is just this planet A we are living in. If we don't save this, we have nowhere else to go. So, before talking about electric vehicles, we need to be very clear that why are we talking about electric vehicles, how we have reached towards electric vehicles, what made us to reach this part of the element of which is ecosystem of electric vehicles. So my my personal work enriches in sustainability transformation with innovation, and I am always very pro of doing three things, which is insight, thinking green, and just being creative with what I do. So basically, this is my passion that I change into my career. So yeah, this is a bit about me. So we go to the next slide. Okay. Why EV adoption? We're talking about why EV adoption. You see how we have reached there. Uh, if you look at the global world, it is working towards some climate change goals. These climate change goals are done and achieved by Conference of the Parties, which is by UNFCCC, UNDP, which is United Nations International Programs. Now, there has been a COP26. In that COP26, it was discovered and it was find out the main obstacles and problems for the climate change. Climate change meaning what is what are we doing in the world that is giving a negative effect to the planet, and in reverse, the planet is giving us floods, more rains, unwanted, I mean, climate change, which is again floods. And you can say a lot of rain comes in. We are happy about it. I hear so many people when they say, oh, there's a lot of rain coming this month. They don't ask themselves why this rain is coming, but they're happy about it. So you should ask yourself why the rain is coming without a season, why there is flood without a season. So all these things are coming up with a reason, which is a climate change. So to tackle that, we came up with conferences such as COP. So COP26, which happened 4 years back, it was discovered it is happening because of deforestation. It is happening for a lot of factors in the climate change, and electric vehicles were a part of it. It was find out that if we go green in terms of sustainability, we can try to save the earth. So climatic goal was to have 1.5 C degree centigrade temperature of the global world, which we are working on. Now, again in COP27 this year in Egypt, they discussed the same thing to bring the whole subject of the global temperature of the world to 1.5 C, and $100 billion was allocated for that fund to different countries. And then by 2050, we have to achieve net zero goal. What is net zero goal? Net zero goal is to achieve a target where there are no emissions from the earth. Okay, to achieve that, there are a lot of things that we can do. We can go to deforestation. We can go free of plastic. We can go with electric cars example. So electric cars were discovered then that if we switch from fuel or diesel cars to electric cars, we can save a lot of carbon emissions, which is already emitting globally. Now, reasons to adopt electric vehicles are very clear to all of us. I don't need to tell you guys that because, first of all, it is not having any tailpipe emissions, and then on the long run, it is silent, which is pollution, which is air noise pollution free, and then cost of ownership is also very cheap in the long run. And we all know today or tomorrow the fuel is going to be over in the world, so we need to shift our energy from fuel to some other type of energy, which is electric energy. Now, again, electric energy can be produced without fuel. Electric energy can be produced with fuel. Electric energy can be produced on renewable energy. Now, what is renewable energy? Renewable energy is like solar and wind energy. This is another subject. It is a vast topic that we can talk about it. So this is just in a nutshell. I'm telling you that how we have reached, why we have reached, and what is electric car doing. Why we talking about electric cars right now? Why we were not talking about it before? Okay. So again, so the race to the net zero was adopted for carbon neutral goals by country, whereas India's commitment towards reaching net zero is by 2070. Only the countries in the world are Suriname and Bhutan are the two countries that are carbon negative, meaning they remove more carbon than they emit. This is just wow. Already in 2022, these are the two countries we already have, they are carbon negative. So if you want to see an example of what is carbon positive and carbon negative, look at Suriname and Bhutan. Then you will know that why we are going towards carbon negative and carbon positive, we are talking about it. So this is a race to net zero globally that I have put for you guys to know and see where we stand in the global world and what are our targets, which is race to net zero. Then again, I have also need to. I mean, I need to also tell you about what is happening in the electrification plans of the global world. So, for example, European Commission, which drafts new laws, agreed that car makers must achieve 100% cut in CO2 emissions by 2035, which would make it impossible to sell new fossil fuel power vehicles in the 27 country bloc. It means in the coming years, in the whole European Union, by 2035, there will be no fuel cars, which is will be by law. Where we have reached in this 2025, Great Britain, and in 2030, you could see all the countries. Um, yeah, and then in 2035, you have in Great Britain again, and in 2040, you have Canada, you have Portugal, you have Germany, in 2050, Germany, and other countries. Similarly, the plans are for the car manufacturers. You can see all the logos are here. I collected for you guys so you know who is going electric and which year they're going electric. Okay. Now, mobilizing the money for net zero, again, we need to talk about how we can achieve this. I mean, we're talking about to reach the target of net zero, but how can we achieve this? So the EV market projected valuation is $244 billion, and then 7 trillion by 2030. This is the market value projection. 46 trillion by 2050. Same as charging infrastructure, investment needed is 10.3 billion by 2021, 2022, 2020, 21, and 939 billion by 2040, 1.6 trillion by 2050. Battery market, $41.1 billion by 2020, $116 billion by 2030, and 16.2 by trillion market of by 2050. Then green and low carbon hydrogen investment needed is for 444 million. Similarly, 1.2 trillion by 2030 and 10 trillion by 2050. Now, this is the investment required if we need to mobilize the EV market, charging infrastructure, battery market, and green and low carbon hydrogen. Now, by the EV dominance, when you look at the EV dominance here, you can see EV could outsell gas cars by 2040. And of course, we all know that in this market, Tesla is the manufacturer which is leading the market. Okay. And here you can also see the other brands such as Toyota is also there, which is just 0.5% of the market. So you can say after Tesla, who is competing with Tesla is probably Tesla itself competing with the other brands. And then it is also competing with Volkswagen, Audi, BMW, and BYD, which is a Chinese market, Chinese manufacturer, and yeah. So this is just in a bit of a EV dominance way that you can see how the EV market globally is changing, and who are the leaders in the EV global market, and what is going to happen by the year 2025 and 2030. So we are saying that by 2040, this market is going to reach in a way that it is going to outsell gas cars, and then similarly, EV charging market will go by $46 billion in 2025. Okay. Now, I'm sorry, why I'm getting distracted because I'm on the lecture side and I'm also looking at your comments. So there is just a bit of distraction. So mind me. Okay. Again, we will talk about the net zero by 2050 scenario requires that sales of new passenger vehicles cars, which includes cars, SUVs, and vans, reach 31% 2025, 64 in 2030, 100 by 2035, in order for the global economy to be on track for net zero emissions by mid-century. Leadership now in this how we can do this in this to achieve this leadership needs to build up their gear towards carbon neutrality. For example, Canada sets first national EV sales mandate for 2026. By 2030, which is not far, uh, 2030 the mandate will hit 60% of all sales. By 2035, every passenger vehicle sold in Canada will be electric. That's an achievable vision, thanks to Canada for setting a goal. By then, but then again, I this is how my personal opinion where it comes in that we as a society, what are we doing? We need to act as a whole towards net zero goal. I would like to mention here Google searches, which was done by the UK nationwide vehicle contract company. It's a UK car leasing group. What are the most laughable comments people have asked were, can electric cars go through the car wash? Can I charge my mobile phone? Can you drive through standing water? These are the three, four Google searches done in the UK. And this is a part of the survey that normal people like us, you and me, including all of us, we have Google searched these questions asking that, can electric cars go through the car wash? Can I charge my mobile phone in my electric car? Can you drive through the standing water? So I'm just telling you, as a society, the perception that we have. So what are we doing to change it? We cannot leave everything to the state. We cannot ask everything and expect the state to design an Armageddon and give it to us on a golden plate. It cannot happen. This is you're living in a natural world. You need to act as a society as well. So from this Google search in UK, a small survey tell us the behavior of the society, that how we think and what is our perception for electric cars. In my opinion, for electric cars, this is my own personal opinion, which I always, make a lot of noise on this, that we need budgeted educational advertising and instead spend a dramatic amount of budget on research and development to come up with an innovative electrifying EV. What am I saying here? What I'm saying here is that a lot of companies in the world, they spend so much big money in the advertising for an electric vehicle against the R&D. The same model why Tesla is successful, because Tesla has no budget, zero budget for advertising, but the entire budget is on R&D. That's why it's number one car in the world. This is the theory that you need to implement. If you want to have an advertising, it should be done in a way that it is educational and people should learn it. And then the amount of finance required should be spent on the R&D so that you can come up with an electrifying EV. Again, consistent education and awareness to our youth, which is you, society, which is you, and community building, which is you again, to reach our ESG goal for sustainable tomorrow is very important. I am proud to be playing this role at my company at EV Technology with similar policies with our electric vehicles OEMs. Electric vehicles OEM means the my original manufacturers. So I play the similar role with them. I always discuss with them because I work as the chief operating officer for the group. So my thoughts and vision are to have a lot of finance for R&D and less on the advertising and marketing budget, and believe in education and awareness to all of you who's listening to me. Okay. Now, in my next slide, I will also discuss with you the regional net zero goals. Now, what do you mean by regional net zero goals? Is that I am living in Muscat, Oman. So so we live in a region called GCC, which is Gulf countries. As per the regional net zero goals, Oman Vision 2040 we have here in Oman already in place. So Oman working on $40 billion booster for green energy projects and targeting carbon neutrality by 2050. So our carbon neutrality goal has been already assigned and designed, and we have to achieve it by 2050, which is a part of Oman Vision 2040, and it's a royal degree. And comparing to that, we have also regional net zero goals of Saudi Arabia, for example, is 2060, 50% by 2030, UAE by 2050, 50% by 2050, Bahrain 2060, 5% by 25, Oman, which I already explained to you. Okay, here I do not have data for Kuwait and Qatar, but does not mean they do not have it. So I just wrote here not available. Okay, so as of now, I have cleared what are electric cars, how we have come to this point of adopting electric vehicles. Uh, if you guys do not understand anything, again, please ask. Uh, I'm trying to be very slow in my conversation so that you guys can catch up. Now, I've explained to you the EV dominance in the world, global the scenario of the world, and the climate change, and the EV adoption. Today's topic is electric buses and designing of powertrain. So let's talk about electric buses. Okay, before we study electric vehicles, I don't want to keep it boring. I want to keep it interactive so you guys are entertained. So I have a small video here to just to share with you that will make you understand electric. Before we study electric buses, we need to understand electrical vehicles how it works. So just watch this video, and I'm sure it will define and answer all your questions.
Electric cars are becoming very popular these days. There are several reasons for a lot of people are continuing showing interest in these vehicles. Because they create less pollution than gasoline-powered or petrol cars. So they are environmental friendly, especially in cities. Vehicles powered by fuel cells are electric cars, and fuel cells are getting a lot of attention right now. An electric car is a car powered by an electric motor, rather than a petrol engine. From the looking outside, you would probably have no idea that a car is electric. In most cases, electric cars are made by converting a gasoline-powered car, and in that case it's impossible to tell. When you often drive an electric car, the only thing that strikes you with its true nature is that it is almost silent. So today, in
Could you please play the video again, sir? It got stuck somewhere in the middle.
Okay.
Thank you.
Electric cars are becoming very popular these days. There are several reasons for a lot of people are continuing showing interest in these vehicles, because they create less pollution than gasoline-powered or petrol cars. So they are environmental friendly, especially in cities. Vehicles powered by fuel cells are electric cars, and fuel cells are getting a lot of attention right now. An electric car is a car powered by an electric motor, rather than a petrol engine. From the looking outside, you would probably have no idea that a car is electric. In most cases, electric cars are made by converting a gasoline-powered car, and in that case it's impossible to tell. When you often drive an electric car, the only thing that strikes you with its true nature is that it is almost silent. So today, in this video, we'll discuss about how an electric vehicle works, along with its parts and functions.
I think there is a problem with the screen in the video. I also realize, and a lot of people are also asking, we need to find a better way again to do this. I
Would it be possible for you to share the screen and then you can play it in your player?
Yeah, I can do that. I'm just trying to do this one first. I hope it works now. This should work now. Because this will answer and define a lot of things.
Electric cars are becoming very popular these days. There are several reasons for a lot of people are continuing showing interest in these vehicles, because they create less pollution than gasoline-powered or petrol cars. So they are environmental friendly, especially in cities. Vehicles powered by fuel cells are electric cars, and fuel cells are getting a lot of attention right now. An electric car is a car powered by an electric motor, rather than a petrol engine. From the looking outside, you would probably have no idea that a car is electric. In most cases, electric cars are made by converting a gasoline-powered car, and in that case it's impossible to tell. When you often drive an electric car, the only thing that strikes you with its true nature is that it is almost silent. To create a magnetic field at the fixed part of the machine, called as the stator, whose displacement sets a rotating part, called as the rotor. The difference between the two is easy to remember. The stator is static, while the rotor rotates. In a motor, the stator uses energy to create a magnetic field that then turns the rotor. What's the difference between an engine and a
Should we go with the screen sharing, sir?
Yeah, we can do that now. Can you see now?
Electric cars are becoming very popular these days. There are several reasons for a lot of showing vehicles, because they create less pollution than gasoline-powered or petrol cars. So they are environmental friendly, especially in cities. Vehicles powered by fuel cells are electric cars, and fuel cells are getting a lot of attention right now.
An electric car is a car powered by an electric motor, rather than a petrol engine. From the looking outside, you would probably have no idea that a car is electric. In most cases, electric cars are made by converting a gasoline-powered car, and in that case it's impossible to tell. When you often drive an electric car, the only thing that strikes you with its true nature is that it is almost silent. So today, in this video, we'll discuss about how an electric vehicle works, along with its parts and functions. Electric vehicles, also known as EVs, do not require IC engines to operate. It is powered by an electric motor, instead of a gas-powered engine. The electric motor gets energy from a controller, which regulates the amount of power, based on the driver's use of an accelerator pedal. The electric car uses energy stored in its rechargeable batteries, which are recharged by common household electricity. EVs move along our roadways without burning up fuel or producing harmful exhaust emissions, while generating less noise pollution. Electric vehicles are like an automatic car. They have a forward and reverse mode. When you place the vehicle in gear and press on the accelerator pedal, these things happen. Power is converted from the DC battery to AC for the electric motor. The accelerator pedal sends a signal to the controller, which adjusts the vehicle's speed by changing the frequency of the AC power from the inverter to the motor. The motor connects and turns the wheels through a cog. When the brakes are pressed, or the car is decelerating, the motor becomes an alternator and produces power, which is sent back to the battery. If you want to understand how an electric vehicle works, you need to be familiar with the physical elements of electric motor. And it starts with understanding the principles of its two major parts, the stator and the rotor. An electric car motor works using a physical process. This consists of using a current to create a magnetic field at the fixed part of the machine, called as the stator, whose displacement sets a rotating part, called as the rotor. The difference between the two is easy to remember. The stator is static, while the rotor rotates. In a motor, the stator uses energy to create a magnetic field that then turns the rotor. What's the difference between an engine and a motor? A motor refers to a machine that converts energy into mechanical energy, while an engine does the same thing, but specifically using thermal energy. When talking about converting thermal energy into mechanical energy, it means combustion, not electric. In other words, an engine is a type of motor. But a motor is not necessarily an engine. With electric vehicles, because the mechanical energy is created from electricity, we use the word motor to describe the device that makes the electric vehicle move. And even if you've never driven an electric car, it's still relatively simple to wrap your head around its main parts. For example, instead of a gas tank, they have batteries. Instead of an engine, they have an electric motor. And instead of a tailpipe, well, they've got no tailpipe. Simple, right? But there are a few other parts that an EV owner should understand. Traction battery pack, power inverter, electric traction motor, power electronics controller, battery, charge port, DC-DC converter, charger, and transmission. Traction battery pack. The function of the battery in an electric car is as an electrical energy storage system in the form of direct current electricity. If it gets a signal from the controller, the battery will transmit DC electrical energy to the inverter and then used to drive the motor. The type of battery used is a rechargeable battery, arranged in such a way that it is called traction battery pack. Power inverter. The inverter functions to change the direct current on the battery into an alternating current, and then this alternating current is used by an electric motor. In addition, the inverter on an electric car also has a function to change the AC current when regenerative braking to DC current, and then used to recharge the battery. The type of inverter used in some electric car models is the bidirectional inverter category. Electric traction motor. The electric traction motors will work turning the transmission and wheels, using power from the traction battery pack. Some vehicles use motor generators that perform both the drive and regeneration functions. In general, the type of electric motor used is the brushless DC motor. A controller unit is an inverter and converter combination that recharges the battery pack of an electric vehicle during regenerative braking, which develops kinetic energy. The flow of energy from the battery is controlled using a controller unit in tandem with the converter and inverter combinations. The DC motor controller system is still used today on some electric vehicles to keep the cost down. However, with the advent of better and less expensive electronics, many of today's electric vehicles are using AC motor controller systems because of their improved motor efficiency and lighter weight. In an electric drive vehicle, the auxiliary battery provides electricity to power vehicle accessories. The charge port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary battery. Charger is a battery charging device. Chargers get electricity from outside sources, such as the utility grid or solar power plants. There are two types of electric car chargers. On-board charger. This charger is located and installed in the car. Off-board charger. This charger is not located or not installed in the car. Thermal system, cooling. This system maintains a proper operating temperature range of the engine, electric motor, power electronics, and other components. Transmission, electric. The transmission transfers mechanical power from the electric traction motor to drive the wheels. There are 4 types of electric cars are available. They are battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, and fuel cell electric vehicle. Let's find out more about these types in details, starting with battery electric vehicle. It is also called an all-electric vehicle, which ran entirely on battery and electric drivetrain. Electricity is stored in a large battery pack that is charged by plugging into the electricity grid. The battery pack, in turn, provides power to one or more electric motors to run the electric car. Examples of battery electric vehicles are Volkswagen e-Golf, Tesla Model 3, BMW i3, Chevy Bolt, Nissan Leaf, and more. Hybrid electric vehicle. These types of cars are often called standard hybrid or parallel hybrid vehicles. This type of car has both an internal combustion engine and an electric motor. In this, the internal combustion engine gets energy from the fuel, gasoline and other types of fuel, while the motor gets power from the battery. The gasoline engine and electric motor together drive the transmission, which drives the wheels. The difference between hybrid vehicles compared to battery electric vehicles is that in a hybrid the battery can only be charged by the IC engine, the speed of the wheels, or a combination of both. There is no charging port, so the battery cannot be recharged from outside of the system. Examples of hybrid vehicles are Honda Civic Hybrid, Toyota Prius Hybrid, and Toyota Camry Hybrid. Plug-in hybrid electric vehicle. It is a type of hybrid vehicle with both an IC engine and a motor. These types of electric cars provide a fuel option. These cars are powered by a conventional fuel, such as gasoline, or an alternative fuel diesel, and a rechargeable battery pack. The battery can be charged electrically by plugging into an electrical outlet or electric vehicle charging station. Plug-in hybrid vehicles typically can run in at least two modes. All-electric mode, in which the motor and battery provide all the car's energy. Hybrid mode, in which both electricity and gasoline are employed. Some plug-in vehicles can travel more than 70 miles on electricity alone. Examples of plug-in electric vehicles are Porsche Cayenne SE Hybrid, Audi A3 e-tron, Ford C-Max Energy, and Mercedes C350e. Fuel cell electric vehicle is also known as zero-emission vehicle, are types of electric cars that employ fuel cell technology to generate the electricity required to run the vehicle. In this type of vehicles, the chemical energy of the fuel is converted directly into electric energy. Examples of fuel cell electric vehicles are Toyota Mirai, Hyundai Tucson, River Simple Raza, and Honda Clarity Fuel Cell. You can charge an electric vehicle by plugging it into a public charging station or into a home charger. But to get the best deal for home charging, it's important to get the right EV electricity tariff, so you can spend less money charging and save more on your bill. How far you can travel on a full charge depends on the vehicle. Each model has a different range, battery size, and efficiency. The perfect electric car for you will be the one you can use for your normal journeys without having to stop and charge up halfway through. An electric vehicle's range is dependent on the battery size. The higher the EV battery, more power the further you travel. Here are examples of how far some electric cars' charge will go. Volkswagen e-Golf ranges up to 125 miles. Hyundai Kona Electric ranges up to 250 miles. And Jaguar I-Pace ranges up to 292 miles. Kilowatts is a unit of power, how much energy a device needs to work. A kilowatt hour is unit of energy. It shows how much energy has been used. For example, a 100 watts light bulb uses 0.1 kilowatts each hour. An average home consumes 3,100 kilowatt hour of energy per year, while an electric car consumes an average of 2,000 kilowatt hour of energy per year. There are 3 electric vehicle charging speeds. Slow charging. It typically rated up to 3 kilowatts, often used to charge overnight or at the workplace. Charging time it takes up to 8 to 10 hours. Fast charging. It typically rated at either 7 kilowatts or 22 kilowatts. Tend to be installed in car parks, supermarkets, leisure centers, and houses with off-street parking. Charging time it takes up to 3 to 4 hours. And rapid charging. It typically rated from 43 kilowatts, only compatible with EVs that have rapid charging capability. Charging time it takes up to 30 to 60 minutes. The main advantage of an electric car is that they're easier on the environment. EVs don't even have an exhaust system, so they obviously have zero emissions. So making switch to an electric car can help contribute to cleaner air and a healthier planet. Electricity is significantly less expensive than gasoline or diesel. Installing solar panels on your home can save you even more money on powering both your residence and electric car. Electric cars do not run on oil, and therefore they do not require any oil change. Also, they don't have as many components that need to be replaced compared to gas-powered vehicles. Electric cars are known to operate smoothly and quietly, as there is no exhaust system. They are much quieter than conventional gas engines, reducing noise pollution and making the ride more comfortable. Electric motors also respond much faster than mechanical engines, providing greater torque and agility while driving. Recharging an electric vehicle is easy, and the best part is, you won't need to run to the fuel station to recharge your car. Even a common household socket can be used to charge an electric car. The main drawback of an electric car is to find a charging station. Even though you can charge an electric vehicle at home, finding a charging station can be a challenge if you're driving through the countryside or on a long-distance road trip. This will continue as demand for charging stations increases. It takes no more than 5 minutes to add gas to the fuel tank, while recharging an electric car can take some time, especially if the battery is completely depleted. It can take up to 15 to 20 hours to get a full charge on the battery pack using a normal outlet. Even the fastest charging stations will take 30 minutes to get to about 80% capacity. Driving range is limited. This can be problematic if you're planning on traveling long distances, but if you charge your car at night, it should be fine for daily commutes. The upfront price of most electric cars is higher than the gas-powered vehicles. Even the most affordable electric car models start from the $30,000 to $40,000 range, while luxury models creep up to $80,000 and more. That's it, thanks for watching. If you still think I've missed anything, or if you have any doubts, then just let me know in the comments. Watch this next video to find out how a diesel car works.
So guys, I'm back here. So when we were talking about how we need to, before jumping to the topic of EV buses, I said you must learn about how electric vehicle works. And this video was specifically designed in very easy language. It has included everything that you need to know how electric vehicle works. Now, in the comment section, I'm also reading that somebody asked that how is it possible to have zero emission? Something like that was a question. So I will answer this now while I'm just doing it. Yeah, so the question was that how zero emission is possible. First, you need to understand that what is zero emissions, which I told you in the beginning, that zero emissions are carbon dioxide which you are emitting from your cars. It could be any negative impact that you are emitting by your by driving vehicles, by driving planes, in the sea, port, etc. These are carbon emissions that you are giving to the environment. How it can be zero? Very good question, by the way. Somebody asked me in the last conference. You see, now the question is, when you manufacture an electric car, how the electric car is manufactured? The factory is using power, probably which is coming by fuel generated electric power grid. So that is not zero emission achievement. And then, for example, there was a big debate. I remember it was about Tesla Gigafactory in Berlin or somewhere in Germany. And there was a lot of protest about it because it was not as per the standards of the city, and people were not happy about it. So what were they talking about? What are we talking about is the same question that you're talking about. That how you can achieve a net zero emission vehicle is that you need to manufacture a vehicle which is produced or manufactured through the process of renewable energy, not through fossil energy. For example, the electricity that you're using to manufacture electric car is coming through renewable energy, not by burning fuel or by burning diesel. In that case, the car which is manufactured could be or possibly be a net zero emission car. Again, one more thing you said that, for example, a car manufactured in China and sold somewhere in Denmark or Sweden or Oman it's not a net zero emission car. Yeah, a car which is made in Oman, manufactured in Oman, and sold in Oman could be a net zero emission car. Why? Because Oman is shifting the production of its energy from fuel to renewables. So similarly, when I said a car manufactured in China and produced and driven in Denmark is not an net zero emission vehicle because it is produced in China. How it is produced, we don't know. But in Denmark and most of the European countries, the energies produced are from renewable energy. So if the car is manufactured in Denmark or Sweden or let's say Norway, uh, they can be net zero emission vehicles because the energy is coming from renewable energy. I hope I replied this and it is clear. Yeah. And now we coming back to the slide. So I explained you that before we study electric buses, we need to understand how electric vehicle works. Second part. Now, top 10 electric buses shaping the world. Again, for this, I have a video because so we don't need to talk about it. So I can just show you my video that will show you what are the top 10 EV buses that is shaping the global world. Okay, so this is, I don't know, I don't think it will work like this. So I'm going to share my screen. So, okay, so in this video,
Top 10
you can see.
electric buses. Electric bus deployment represents a major trend in the international landscape of urban public transportation. Many companies are now focusing on electrification of their mass transit solutions, and several factors such as the rise in pollution and environmental hazards, stringent government regulations, and stiff competition have compelled several automakers to make environment-friendly buses. Here is a list of the top 10 environmentally friendly buses. You wouldn't want to miss the amazing facts about the number 1 bus on this countdown, and let's get down to it. At number 10, the BYD K9. The 12-meter length BYD K9, simply referred to as the BYD e-bus or BYD electric bus, is a low-floor, single-deck city bus manufactured by BYD in China, utilizing BYD's proprietary iron phosphate battery. This vehicle is quiet, comfortable, and powerful. It has a range of 250 kilometers or 155 miles on a single charge under urban road conditions. BYD K9 is a vehicle built mostly for urban use, and its passenger capacity is configured based on customer needs. It has a low platform and a ramp for wheelchair access. The bus is 13 meters long, 2.55 meters wide, and 3.3 meters high, and it weighs 13.5 tons. The bus is driven by 2 electric engines with a total rated power of 245 horsepower. It can reach a maximum speed of 96 kilometers per hour. The battery pack can be physically arranged into various configurations depending on the vehicle bodywork and the operating company's requirements. The most frequent position is on the wheel columns. Batteries are regenerated, which means they recover part of their load when braking. In addition, the solar panels on the K9 roof provide additional energy. Number 9, the Proterra ZX5. The Proterra ZX5 is a battery electric transit bus available for sale in the United States and Canada. Available in 35-foot and 40-foot lengths, it's the company's 5th generation of battery electric bus. The ZX5 was formally launched in late 2020, replacing the Catalyst line of buses. The ZX5 features the same fiberglass and balsa wood body structure as the Catalyst, but incorporates design changes to both increase battery capacity and standardization with electric vehicle charging protocols. The overall appearance of the vehicle has been made more angular, while the roof fairing has been made more streamlined with provisions for roof-mounted battery packs, as well as integrated roof charger rails. The redesigned roof fairing has also resulted in an overall decrease in the vehicle's height by 6 inches compared to the Catalyst. The standard ZX5 model with a 220 kilowatt per hour energy storage system can travel up to 201 kilometers on a single charge. The ZX5 Max is the longest range option available. With a 660 kilowatt-hour energy storage system, the ZX5 Max can travel up to 529 kilometers on a single charge. Number 8, Shipe Busorio 4X.
The Oreos 4X is a 49-place electric minibus of the Jeppe Bus line of products, made for the operating of some urban regular lines or also a private usage as airport shuttles. The Oreos 4X is among the first entirely electric autobus produced in France. This clean vehicle belongs to a new generation, more efficient for the power than the older models, and therefore helps to reduce the environmental impact of the transport in the cities. The Oreos 4X uses lithium-ion batteries, which can be reloaded without the use of a battery charger, because this charger is included in the bus. The battery can provide up to 120 kilometers or 75 miles of range with a maximum speed of 70 kilometers per hour. The bus is also equipped with a wheelchair access system. Number 7. Mercedes-Benz e-Citario G. The new e-Citario is the first fully electric-driven articulated bus bearing the three-pointed star. With space for up to 164 passengers, it stands both for sustainability and efficient passenger transport in urban centers. The body of the vehicle is based on the Citaro G with a combustion engine. The roof is based on the Citaro G NGT with integrated heavy-duty rails. The 18-meter-long bus is available in 3 doors and 4-door versions. One of the 4 or 3 doors is fitted with a wheelchair ramp so that passengers with restricted mobility can enter the vehicle without obstruction. Commuters can also enjoy USB ports for their devices and an efficient climate control system on hot summer days. The e-Citario G is equipped with innovative solid-state batteries, and with this battery concept, Mercedes-Benz takes the technology lead not just in the bus segment, but in automotive construction worldwide. Number 6. eBusco 2.2. The eBusco 2.2 is a very innovative electric bus. eBusco supplies the 2.2 in 4 variants: the 12-meter bus, the 13-meter bus, 13.5-meter, and 18-meter bus with its 350 kilowatt-hour battery pack. The eBusco 2.2 can run a range of up to 350 kilometers with the optional 400 kilowatt-per-hour battery pack. The eBusco 2.2 can run a range of up to 450 kilometers. eBusco 2.2 uses the LFP battery technology, which provides a high energy-to-weight ratio. This battery technology gives the bus a longer useful life and enables battery warranties. Number 5. eBusco 3.0. The eBusco 3.0 is designed to be a game changer in the electric bus industry. Its revolutionary design allows for more comfort due to the spacious and luxurious interior, coupled with considerable noise reduction both inside and outside of the bus. The fully flat floor throughout the bus allows for maximum window size. A panoramic window in the roof is possible as batteries are all mounted on the floor. This leads to excellent visibility throughout the bus due to the increased natural incidence of light. An increased interior width of up to 90 centimeters between the wheels arches leads to increased freedom of movement, flexibility, passenger flow, and timely operation of the bus. Outside mirrors are replaced by cameras, thus increasing the safety and aerodynamics of the bus. Automatically adjusting driver seat, dashboard, and camera mirror systems fit the driver's workplace around the driver. The eBusco 3.0 is designed for overnight charging due to its lightweight and high efficiency, offering maximum flexibility in daytime route adjustments and allowing for charging during low nighttime energy rates. A full composite body reduces maintenance costs considerably and extends the operational lifespan of the bus beyond 15 years. The lightweight design increases its range substantially, which can be up to 500 kilometers on a single charge. Number 4. AB Volvo 7900. The new Volvo 7900 Electric is so much more than an electric bus. The Volvo 7900 Electric can run everywhere, silent and clean with no climate emissions. It can go where people want to go. The new Volvo 7900 Electric is available with a choice of 150, 200, and 250 kilowatt per hour. This means that the bus can run far longer between charges, allowing it to be utilized more efficiently throughout the day. And just like the former Volvo model, the batteries in the new Volvo 7900 Electric can be fast charged at their routes and stops via the open and competition-neutral off-charge interface. However, they can now also be charged via cable, which is the European standard for charging electric vehicles from the main grid. Number 3. Electrobus Model E420 VVOF Electro. Electrobus Number 2. Electrobus E433 VVOF Max Electro. Electrobus Model E433 VVOF Max Electro is a 3-axle, low-floor linked type of vehicle, which is equipped with the supercapacitors and able to overcome the route offline, charging on the route terminals. The use of CAN bus technology enables monitoring and diagnostics of the technical status of the Electrobus. This latest model provides every conceivable aid to people of restricted mobility, including a folding ramp. The VVOF Max Electro is a real-life example of how functional material combinations packed in a fresh design can undoubtedly become a welcome addition to any cityscape. The Max Electro features an airy, bright, and clear interior design adaptable to customer requirements. The internal cover is made from composite materials and aluminum panels. There is full air conditioning for the entire vehicle, employing 3 separate air conditioning units, and also high-performance heating. Just like the E420, the partition between the driver's cab and passenger compartment is also glazed with a gap for ticket sales. Number 1. Yutong U12. Yutong U12, a pure electric 12-meter long bus, is built with the aesthetic essence of modern bus design and passengers' comfortability. The overall styling is integrated, being simple and harmonious. The bus body outlines a strong and straight posture, turning out to be a mobile and stunning scenery of the city. The bus employs a new design language for all its digital systems. With large black surfaces, the entire vehicle is stylish and elegant. The arc on the front top creates a conspicuous outline for the vehicle. The vehicle's overall styling recalls the appearance of a digital gadget, offering strong affinity and friendly interaction with passengers. It has electric air conditioning with a cooling capacity of 38,000 kilocalories per hour, a heating capacity of 36,000 kilocalories per hour, and forced fresh air ventilation, which ensures a consistently comfortable passenger compartment. Passenger seats offer ergonomic design and USB charging ports to accommodate portable convenience. The energy supply is provided via a 422 kilowatt-hour battery, which ensures a maximum mileage of up to 400 kilometers on a single charge. According to the automaker, the Yutong U12 can accommodate up to 85 passengers and 2 wheelchairs or prams. This is where we draw the curtain on today's video. Which of these electric buses did you find most amazing? What do you think about the future of electric vehicles in the years to come? Let's hear your views or opinions in the comments section. We'll be glad to hear from you. Subscribe unless you're into electric vehicles, because that is what this channel is all about. And now, let's watch another event.
Okay, guys, so you have seen the top 10 electric buses that is shaping the world. This video that I specifically designed for you, so you know what are the electrification of buses happening around the globe. Now let's go back to our other slide. Why China is leading in EV buses? If you looked at the slides, look at the last video, you must have seen the China is leading in EV buses. There are a couple of reasons which is also can be defined in the video, which I will show you instead of talking, because I think talking is more boring than the video illustration.
Around the world, electric vehicles are gaining momentum, and there's no place where the EV Around the world, electric vehicles are gaining momentum, and there's no place where the EV revolution has taken hold. China. The world's largest car market is leading the charge in the adoption of zero-emission vehicles, largely due to government subsidies and mandates. And while most of the attention on mitigating pollution is directed at passenger cars, the Chinese have prioritized another area that will have a bigger impact: buses.
In 2018, 80,000 globally, 99% of which were delivered in China, made that approximately 89% of all electric buses delivered globally will be delivered in APAC by 2025.
To the credit of the Chinese government, they realized very early on that this transition globally was going to take place. China very strategically looked at markets like urban cars and urban buses, and they have been spending billions of dollars to move them off of oil. And if you look at the impact that that's had on China, they have reduced their daily oil consumption by over 200,000 barrels of crude oil.
Buses consume considerably more fuel than the average car, making the transition to electric significant in reducing consumption of fossil fuels.
Buses are responsible in many cities for the majority of specific pollutants and tailpipe emissions. That's because they drive a lot of miles per year, and they're very fuel inefficient as diesel applications.
The more cars they could take off the streets in China, the more importantly, more of the diesel buses they could take off the streets would help air quality in China.
In the US, however, the adoption of zero-emission buses is happening at a much slower pace. Interact Analysis says the US had just 300 buses delivered in 2018, compared to the 78,000 in China.
I think our biggest obstacle here in the U.S. is that we're slow to adopt to new ideas, and we get very comfortable in just the status quo.
The company that delivered the majority of U.S. buses last year is Bay Area-based Proterra.
We're coming up on 100 customers, and we did 25 deployments alone in 2018. So we have buses at Yosemite, we have buses in New York City, we have them in Seattle, we have them in Dallas, Texas. We also have them in a lot of small fleets like Missoula, Montana. So we went through the effort of designing a vehicle from scratch to be an electric vehicle. And that meant rethinking a lot of things that you do in a bus, where the motor is going to be located, where you put the energy storage. But ultimately, that gets you to a much higher performance design. And that's why our vehicles have a better handling characteristic and longer range than previous attempts at electric buses.
Before joining Proterra as CEO, Ryan Popple got his start working at Tesla.
Companies like Tesla are doing a phenomenal job in terms of changing this market and changing mentalities around passenger cars. And so the opportunity we have at a company like Proterra is to take state-of-the-art EV technology and make it accessible to every single rider in a city.
Compared to diesel buses, battery electric is far more efficient and can result in significant cost savings for transit agencies.
Our buses use around 2 kilowatt hours of electricity per mile. And if you take the average price of electricity in the US, that's about 10 cents a kilowatt hour. So you need 20 cents of electricity to move our bus 1 mile. Diesel buses, they only get 4 miles to the gallon, and that's on a good day. So if you take today's diesel prices in California, you're probably burning 80 cents of diesel fuel per mile that you drive.
While adoption of battery electric buses has been slow, state mandates are starting to expedite that process. New York City, the largest transit agency in the US, has plans to take its fleet all electric by 2040. And California has taken an aggressive stance in reducing vehicle emissions, requiring all new buses to be zero emissions starting in 2029.
As of December of 2018, the California Air Resources Board voted 12-0 that the entire bus fleet of California is going zero emission.
When that happened, it was a pretty bold statement, but my own personal belief is that transit operators everywhere are going to move in that direction much faster.
San Jose Airport recently converted a portion of their shuttle fleet to Proterra electric buses.
San Jose Airport, as a microcosm, it's an example of what we think the entire bus industry could look like 10 years from now.
The major thing in deciding to get electric buses was really the initiative that our city has and our mayor has for sustainability and going green. Right now, we're in a bit of a transition phase where we have our current CNG fleet mixed with our electric fleet. But here very quickly, we'll slowly phase out our CNG fleet.
These vehicles are part of the city of San Jose's long-term sustainability plan. They have a path to run on 100% carbon-free electricity. So they are zero emission today to the local community, and their future is to be a zero carbon transportation system as well.
North of Los Angeles, Antelope Valley Transit Authority is on track to be the first all-electric metro fleet in the US. Their e-buses are made by Chinese company BYD.
By the end of this year, we'll have all our local transit fleet will be electric. Only diesel buses will be left to the 30 or so commuter vehicles that take our customers down to LA.
To power these buses, Antelope Valley is turning to solar power.
We have enough solar capacity on hand now to run the maintenance shop, the administration building, basically everything but charging the buses. So we've been in negotiations with a couple different solar providers to provide the rest of the solar we need to be 100% off-grid and a fairly sizable battery pack so that we can also charge at night.
Antelope Valley says solar and battery power are more reliable than fossil fuel or charging the buses on the traditional power grid.
Any fuel type is subject to interruption. A few years back, there was an earthquake that broke the natural gas lines that ran into Oxnard, diesel fuel lines can be cut off, a refinery explosion can shut off fuel supply. But I feel really strongly that with solar and battery storage, that we'll have more resilience than any other fleet or fuel type currently running in North America.
Since converting their buses to battery electric, Antelope Valley has seen a few benefits.
We avoided 1,300,000 tons of greenhouse gas emissions. We avoided 285,000 gallons of diesel fuel, which saved us about $500,000, and that was just with a third of the fleet and 1 million miles. Those numbers extrapolated out to 12 years equals $65 million of savings. So not only is it good for the environment, but it makes economic sense.
Being a pioneer for an all-electric fleet, Antelope Valley has garnered the interest of other municipal agencies evaluating the technology for themselves.
The response has been overwhelming, and we probably get 5-6 requests a month for tours of the facility, show people how our infrastructure is working, our charging systems are working, and we're living proof that it works, it saves money, and actually the vehicles are more reliable than our legacy fleet of diesel and hybrid vehicles.
But there is one area where questions remain: the charging infrastructure.
Strategically all around the valley, we've got in-route chargers that wirelessly charge the buses over an air gap. So when the bus pulls into the transit center for its normal 10-minute layover while customers get on and off, it's actually picking up a brief charge too. And by doing that 7 or 8 times a day, we add 100, 120 miles of range.
BYD, the company that makes Antelope Valley's buses, has a manufacturing plant in nearby Lancaster, California.
We've been here about 6 years, and we're producing roughly around 7 different models of electric buses that are earmarked for use in the United States at transit agencies, universities, large employer campuses, and airports.
Though it originally started as a battery company, BYD is now the world's largest EV manufacturer.
We're not only in China, we're in the UK, we're in South America, we're in Central America, we're in Mexico, we're in the Caribbean, we're in Canada. So again, it being a global problem, BYD wants to be part of the global solution.
Aside from the environmental benefits, electric buses are also less prone to maintenance issues and are cleaner to work on.
It's fun to take these out, show the maintenance people, and they're often very surprised at how simple and elegant the design is. They're used to a massive diesel engine that's dirty and it's incredibly complicated. And these vehicles are very, very simple to operate and maintain.
The way diesels are able to stay on the road right now is they have particulate traps that trap the soot, basically, the diesel exhaust produces. When you get the soot out, it becomes a hazardous material. It has to be disposed of through the EPA hazardous material disposal process. It's also very expensive because you're sending it essentially to a landfill meant for hazardous material.
It's actually got 30% less moving parts. My job's a lot easier as far as, troubleshooting and figuring out what things may be wrong at the time.
While China may be in the lead in number of e-buses in circulation, some believe that the U.S. still excels from a technology standpoint.
This renaissance of manufacturing, design, and engineering that's happening in the electric vehicle space, a lot of the best work is being done in the United States. We want to make sure that we have a competitive advantage in the world as the world transitions to cleaner, quieter electric vehicles.
We'll never catch them just from population and demand for vehicles, but I think technologically we're there, and I think that we're going to continue to improve to where we might be ahead of them sooner or later.
The fact that the US is growing is a great sign. We saw more than 100% growth in 2018 compared to the previous year. We estimate there to be about roughly about 2,000 electric buses delivered annually by 2025 within America.
And as more electric buses make their way into U.S. public transit systems, the companies making the vehicles say their technology can be used far beyond city buses.
School buses should be coming right on top of that. We have a partnership for coach buses, and we're also partnering with a UK manufacturer for double-decker electric buses. And eventually we're going to see these into trucks for delivery locally, things like garbage trucks as well. We think pretty much every heavy-duty vehicle that you see out there in our cities and towns is going to be electric at some point in the near future.
It's really a no-brainer. The economics are there, the benefits ecologically and environmentally are there, And I think what China's done is showing leadership to the world, funding and pushing forward their own fleets to get green and clean. In the United States, we've got probably 5 companies now that are doing electric buses, and virtually every automaker is introducing an electric vehicle. So I think the change is here for good.
So coming back to my presentation, I would just so you just watch the video and know from the video that why China is leading in EV buses. Who are the top EV manufacturers? You can say Yutong and BYD. BYD is anyways the largest EV manufacturer of electric vehicles in the world. Uh, Now coming back to the next slide, top EV bus leader. Uh, Top EV bus leader, although the race also states that BYD is one of the world's leading new energy vehicle manufacturers and the world's leading electric bus manufacturer. Solaris Bus and Coach, Volvo Group, Yutong Bus Company Limited, VDL Bus and Coach PV and Hyundai Motor Company are also the leading players in the global electric bus market. Now, for today's session, my last video of the day, because then we will start a very thorough analysis of electric bus power management system, power battery system. Okay, so this is the last video. After that, you will not be watching any video. This is very important video. I want you to watch it. Why? Because it is telling you about the battery in principle.
Newton has a rich operating experience in the full electric bus area. As a full electric bus, what is the main technical principle of E12? In the drive phase, the vehicle controller sends out signals to the integrated controller. The battery will provide power to the drive motor through the integrated controller. Then the drive motor will transform the electric energy into mechanical energy to drive the vehicle via the drive axle. While taxiing and braking, the vehicle controller sends out signals to the integrated controller, and the integrated controller will control the drive motor to transform the kinetic energy into electricity to charge the battery so as to achieve the recovery of braking energy. Under the external charging status, the battery can be charged through the charging device, which gets electricity from the power grid. This is the main principle of E12.
So you saw the top EV leader, bus leader. I took an example of Yutong because BYD and Yutong are one of the top leaders in the global world. And you saw how the electric battery of the bus in the real practical case works. Moving back to the new slide. Types of batteries, power charge. Types of batteries, power, charging, and battery capacity. Now we need to know that what kind of batteries are there. A typical electric bus powertrain configuration consists of an energy source, for example, battery, a single traction motor with controller, and a final drive differential gearbox. Alternative configuration are two traction motors with the reduction gears near the wheels or 2 to 4 in the wheel motors. Now, in this diagram, if you look at it, it is typical efficiency map of synchronous PSM and asynchronous motor ASM. Now, I know these are very difficult terms for you, even for me, because these are very engineering terms. But these are typical terms and efficiency to derive the efficiency of the electric battery, which is in the buses. Now, again, cell charge current and the cell charging power for different cell types are also there. So cell charge current and cell charging power I've also mentioned there. Again, for you to know and understand that I'm sure these are very difficult terms for you to understand. Even for me, as in terms of understanding, they are difficult at times to know how the types of batteries and the power and charging battery capacity works. I can see one of the question was that how what kind of charging station is required for the electric buses. Now you see that electric bus treated as an electric car. You need an AC charger, you need a DC charger. Yes, for a fact that the bus ecosystem or charging the electric buses require a lot of maybe more expensive charging infrastructure. Why? Because it needs to be DC. Buses are on the go. You cannot just keep one bus for 6 to 8 hours. So you need a DC charging system, and of course, DC charging system infrastructure is very expensive. And having said that, DC charging system for the buses are also very typically designed. It's designed in a way that you can charge. That I've seen and witnessed myself in China, that there are buses that can be charged in 10 minutes on a DC charge, some on 5 minutes. So the infrastructure is very expensive and it's specifically designed depending upon case to case. Okay, so types of buses with batteries, power charging, and battery capacity. Now, this is in a nutshell. I have described to you, for example, 40 to 60 feet transit bus. If its OEM is BYD, OEM means the manufacturer is BYD. Maximum power required is 180 to 360 kilowatt. Battery capacity is 324 to 548. Charge power capacity is 40, 80, 100, and 200. So is for 30 kilowatt, 30 feet bus. CCW is the OEM. Maximum power, motor power, I don't have it. So battery capacity 311 and 40, same as charging power. 34 to 40 feet transit bus design line, 335 maximum motor power. So what we are trying to explain here is different types of bus with different capacities of batteries, what kind of power and charging and battery capacity is required. And this also answers the question of how you can charge an electric vehicle, how much time it requires. So depending upon the battery capacity, charge power kilowatt, and maximum motor power requirement, it defines the time of charging. Coming to our next slide is about battery type and leader. Now we need to know that what type of battery is required for electric buses. Lithium-ion batteries have entered every segment of our life, from our mobile phones and power tools to electronic bikes and cars. The race for more energy and more power is on. The main driver behind that race is the progress of technology used in the Leon cells and batteries. The key parameter here for any electric vehicle is energy consumption, measured in kilowatt per kilometer, is predominantly connected to the vehicle's weight. So, in the e-bus segment, the race to reduce the total weight of the batteries to gain the highest energy density is really fierce. The three most popular types of lithium-ion technologies are LTO, LFP, and NMC. These acronyms are derived from the type of minerals used in the cell chemistry. Each of them have some unique characteristics, but according to the BMZ, Poland, which is a company, it is NMC that has been winning the race thanks to its universality in both car and commercial vehicle applications. Not only does it win the energy density contest, but it is also the leader when it comes to unit weight and volume. The BMZ group has manufacturing facilities in China, Poland, and US, as well as in Japan, UK, and France. While nearly all modern electric vehicles feature some from lithium based battery, various cell chemistries exist whose technical parameters differ significantly. The most important characteristics of a specific cell type with regard to electric bus operations and energy density, charge rate, and cycle life. Currently, lithium iron phosphate (LFP), lithium titanium oxide (LTO), and lithium nickel manganese and cobalt oxide (NMC), which I explained to you before, are the most common cell types encountered in electric buses. So these are the types of battery required, and these are the types of battery used for electric buses. These are the names of the leaders of the battery used in electric buses. So the next slide. What voltage do electric buses use? This is a very important question to know and understand. Level 2 charging stations are preferable for electric buses since they use a 240 volt or 208. Here I answer the question of you guys asking me what kind of charging is required. Uh, so level 2 charging stations are preferable for electric buses since they use 240 or 280, 208 volt plug for faster charging. DC fast charging stations can provide even faster charging. These stations use a 480V AC input. Electric bus range focus on electricity consumption. I have done a small sum up of 12-meter bus. So like a case scenario I have done for you guys. So it's easy to understand. Vehicles heated with the help of an auxiliary fossil fuel heater consume from 110.5 kilowatt plus 20 liters of fuel to 144 kilowatt plus 6.4 liters. Power consumption of buses with full electric heating diluted over 100 kilometers stands in the range between 175 and 225 kilowatt hour. In other words, consumption is reported to span between 1 and 1.4 kilowatt per kilometer on buses with fossil fuel heating system and up to 2.35 for electricity heated ones. Sorry. That is to say, taking as a sample as a solo bus with considerable battery capacity of 300 kilowatt, range of the electric bus varies from 214 to 300 if diesel heated and as low as 130 kilometers electricity heated. A huge difference. On average, a 12-meter bus has, in the best conditions, a consumption of zero point 0.8 kilowatt per hour per kilometer. We are talking of operations in a normal day with 20 degrees. No much traffic and a skilled driver is driving the car. Everything depends on the heating. A bus operating in the winter, for instance, at minus 10 degrees with electric heating turned on can reach a consumption of 2.3 to 2.5 kilowatt per hour per kilometer. With diesel heating, it could be 1.5. So these are the case scenarios that I took for a 12-meter bus, and what is the best case scenario for charging, and what is the mileage you can achieve, and the temperature and the ambient also matters, and the level of charging station required for charging electric bus. This is another video that I have. Which battery? Okay, which battery which battery is used in electric bus? The battery warehouse consists of lithium-ion electric bus batteries. They are installed in a battery chamber and linked together to create a specific required kilowatt per hour storage pack. Which battery is best for electric vehicles? Most plug-in hybrids and all electric vehicles use lithium-ion batteries like these. Energy storage system. Usually batteries are essential for hybrid electric vehicles, plug-in hybrid electric vehicles, and all electric vehicles. There's a video to show you, and I think I have to go back and okay, so this video is not available now. I have in my slide, but I cannot show you because of the process of the platform. So let's go back, just jump to the next slide. Okay, so comparison. So the next slide is again comparison of the NMC, which is the electric vehicle battery, LFP and LTO technologies developed with regard to energy density at the cell and battery pack level source, BMC Poland. Now, what is this? This is about the weight of the battery. For example, what we are doing is a comparison that if we use NMC, LFP, and LTO technologies development with regards to energy, what is the battery pack level required? So cell chemistry, NMC, LTO, NMC as an example. Total energy of the battery set required is, for example, 310 kilowatt. Charging time required to cover approximate 50 kilometers, 12 minutes. With LTO, it is 12 minutes. With NMC, is 13 minutes. And depending upon, again, the total energy of the battery set, 1,800 kg, the weight, 300, or it's different if it is 3,000 kg. Average mileage range with no additional charging at 1.2 kilowatt per hour for 1.8 ton and 1.3 kilowatt hour. So this is basically a small scenario and the cases that I have put forward all together, because the question is that what is the weight of the bus and what kind of battery you're using, NMC, LTO, NMC technology, what charge you're putting into the vehicle for battery charging. So in this case, how many minutes you can charge the vehicle to achieve 40 kilometer, for example, and depending on the weight, it differs. Uh, Here in the other graphs that you can see, it is about EV battery, e-bus battery technology comparison. Now we are looking at the evolve of the battery. NMC is a cell level, LFP is a cell level, LTO is a cell level. NMC, which you can see is blue, NMC pack level, and from 2013 we can see that we are, in terms of the comparison of e-bus battery, the technology is moving forward by 2022 2023. So this is the statistics that you need to know. I know this is a lot difficult for you to understand, but this scenarios and cases and the battery types and the charging system, the weight of the vehicle, the ambience, all depends upon the designing of the battery of the electric vehicles. And all these scenarios and collectively put together defines how many kilometers electric bus can go for. Because a lot of people ask this question that, okay, I'm charging the vehicle. Let's take an example of electric car. I'm charging my vehicle. How many minutes do I need to charge my car? This is a very simple question that everybody asks, and I'm sure for the buses it stands the same. So it all depends upon your battery. I cannot tell you, and upon your car, that if I can give you DC power, DC charging station, maybe it can do a quicker job. But then again, your car should be able to take DC charging port. I have vehicles that cannot take DC charger because these are small vehicles. I have a 20 kilowatt vehicle, sorry, 30 kilowatt vehicle, which cannot be charged by DC. It can only be charged by AC. So it takes about 6 to 8 hours to charge the vehicle by AC. And again, that AC differs, 7 kilowatt or 22 kilowatt. If it's 22 kilowatt, it's much faster. Same is similarly for the bus. There are a lot of factors involved for charging the battery and the designing of the battery, and what type of material is used, what its NMC, LFP, LTO technology is used, what kind of technology is used, what is the weight of the battery. Okay, so here we are coming to another thing: input and output data for bus system simulation. Now you see again operational data, line characteristic, velocity profile, altitude, including passenger occurrence, climate data, temperature, etc. Battery and charge system. This is a bus system simulation. Battery, cell properties, battery type, volume and weight, as I told you, discharge curve, capacity, wiring, SOC, charging system. Then the vehicle data itself has body type, curve, weight, maximum additional weight, and then front area, drag coefficient, drivetrain. These all, if when you put into simulation model, then it comes to energy consumption, required charging time, additional weight, charging efficiency, regeneration factor, aging of battery, reciprocation rate. As I said to you before, that again, input and output data, when you put in a bus simulation, bus system simulation, you need to keep all these factors in mind. Then you keep all these factors again into a simulation model to produce the results. So when you produce the result, your results would have again energy consumption, you will ask and then required charging time, additional weight, charging efficiency. These are all again leading you to the battery management and the designing of the electric vehicle battery system. These are the factors, these are the input and output. And I know it's a lot difficult. Okay, now we're moving to the our last few slides. Passenger cabin HVAC system model image. This is also very important part of your body, of your vehicle to understand, which affects your mileage, your battery, your power, your strength, and everything. So passenger cabin HVAC system model image. This figure is showing you the heat flow and the mass flow. In inner thermal mass, then isolation is required, which you can see on the top of the bus. Then exit air is also there on top of the bus. Heat exchange with environment, top of the bus. Fresh air is coming. Then the recirculation of the air is happening. This is HVAC system. Passenger cabin is there. Air exchange through opening the doors. When you open the door, there is an air exchange. Maybe it's a hot weather outside. It's an AC inside. So there's an exchange. Again, it's an effect. So supply of air is also coming through HVAC system. The recirculation of the air that if you look at the AC of your car, it has ventilation mode, it has recirculation mode. So it is called HVAC system. So heat and vapor released by passengers. Again, when the passenger is sitting inside, we are also evaporating and vaporing released by gas, in terms of breathing. Yeah. So these are again all the factors, passenger cabin airbag system model. Why are we talking about it? Because these are also playing a very important role in your designing of the battery. That's why the electric bus differs as per the region, as per the climate conditions, weather or summer, whether it is India or USA. It is designed specifically for the region. Now we coming to the next slide, which is the end of our presentation and the lecture. Conclusion and future work. The transformation process from diesel to electric bus system opens a very large design space. Energy consumption is analyzed considering the characteristics of different electric powertrain batteries, as heating and air conditioning are typically the most energy consuming auxiliary electric buses. Special attention was given to the HVAC system. As I said to you before, that this is very important factor, and based on these factors, the buses are designed as per the region, country, city, and state. With the help of a verified, the bus that can be used in Oman or can be driven in Oman, I highly doubt it. It can be driven in India, because I saw the question in the comment box was that why the buses are lowered. I don't know if I get the right question. So these are different factors. The buses are designed as per the region. Maybe your roads are that type that the vehicles should be designed as per that. Maybe you have a specific size of jump. Jump means the hump that you have when you're driving a vehicle. So based on that, the vehicles are designed. And again, when you look at the electric sports car, the sports car, you will see that those cars are designed lower, at a very lower grade. Why? Just to have a better what do you call that word? Traction control to the wheel can get a better traction control to get the friction from the floor, from the cement. So these are the factors that you need to understand that before that why the buses are lowered, why the buses are lowered. Again, depending upon the area and the location and the design, or maybe the ambience of that city. With the help of a verified modular simulation model, the vast variety of theoretical system solutions can be reduced to a subset of technically feasible variants. The final technology selection is based on a detailed economic analysis, which is conducted by means of a TCO model. What is TCO model? Is the total cost of ownership. Also, it can aid original equipment manufacturers of electric buses and related infrastructure in making systematic design decisions. Electric bus systems are technically feasible and can become economically competitive for the year 2025, and we have identified OC as the most suitable system or solution considering available technology and operational requirements. Furthermore, it can become necessary to adapt vehicle schedules to technologies, operational constraints. In the opportunity charging system, for example, it is possible that turnaround time at terminal stops has to be increased to allow sufficient charging time with DC. On the other hand, existing vehicle schedules may have to be split into account for the limited vehicle range. So this is, in conclusion, in the future work that how we are going to achieve the future of electric buses. I've also shown you the top 10 electric vehicles that is shaping the world. If you see, there are more of modern technology has been used already in Europe, and technology will change. We have seen the evolving of iPhone. I remember that iPhone that I had back in the time was the size of a brick, and I don't know, now you have iPhone 15 and 12. So, and then this is how the technology will evolve. the transformation will take place, and so are the buses and the designing of their battery management system, and so are electric cars. I mean, I know personally people that I cannot name them. They are working on portable EV chargers such as USB. So imagine that your technology is going that far in the coming years. So any questions of you are very much welcome, please. Neha, if I would just like to say thank you to all of you for listening me, and I am sure I was very boring because I did not name Neha told me it's a lecture, but I would. That's why I try to make it as informative in terms of as informative, interactive in terms of the videos, because videos are something that can illustrate more than my conversation. Thank you so much, Neha, and thanks to all of you for listening to me. And Neha and your team and your students or trainees have any questions, please feel free to ask.
Yes sir, there are certain questions.
Yes,
आप
please.
लोगों को कोई भी क्वेश्चन पूछना है तो टाइप करिए, आप हिंदी में पूछ सकते हैं. आई विल कन्वर्ट इट. अरबी मुझे नहीं आती, उर्दू पढ़ लेती हूँ मैं. अनी संतानिया, could you please type it in Urdu? I can read Urdu but not Arabic. Okay. So there's a question regarding the battery. It's asked that we have often heard that the battery of electric vehicle, they get burned. Why does it happen?
Sorry, I did not get the question. Can you ask the question again?
It's regarding burning of the battery of electric vehicle. Why are the
Okay.
batteries burning?
Good question. I mean, you see, it's again, it's a myth, and there are a lot of whoever has asked, please go to the source. A lot of myth is there, a lot of fake news has been spread, and I have seen a lot of videos also circulating. Sometimes I see it's mostly in India, and it is happening with the I think motorbikes and also with cars. Now, why electric vehicle batteries are burning? Okay. First of all, you need to ask the question, which car are you talking about? What was the term and condition of the car? What really happened during that incident? You know, again, it's very easy to pinpoint and blame a finger to the manufacturer. But it all depends how the electric vehicle battery was burned, which I personally assure you that I have no case read whatsoever, other than unless I think it wasn't about Tesla. If I remember that there was a case of battery burning. I don't want to say Tesla because I don't want people to use it against me. But there was some car. But then again, the research was that done about how the electric battery was burned. It was not blamed after the EV manufacturer. It was blamed after the conditions and the type of way you're driving the car. Because you see, you need to understand that driving habits can change anything in the car. Similarly, I have a friend that I have electric car that I'm driving at present right now. But I give this electric car to my friend. He will finish the battery within probably half an hour. And I ask this question to myself, what does he do that I cannot do? Or maybe what is he doing that I'm not doing? So probably he's speeding up, he's misusing the car, and he's using and blasting the AC on the full, and the air conditioner is on, and the music system is on, and he's over speeding. Now, again, all these factors cannot burn the battery. Don't worry about it. In any case, the battery is designed in a car in a way in so many layers that for a battery to burn and to reach to a capacity to burn, it needs a lot of capacity, lot of high capacity. Batteries are designed to sustain in heat. Batteries are designed to sustain in snow and in winter. So I highly doubt that why an electric vehicle will burn its battery, and I would like to see it myself.
Okay, I'm hoping that the student is satisfied. There is another question regarding the safety. When will
Yeah.
it be safe to say that now the battery manufacturing is completely carbon free?
Wow, it's a stage, evolve, transformation, sustainability, development. It's a lot is going on. So, carbon-free manufacturing of battery you're talking about?
Yeah, the
It
student
is,
is
it is
curious about the carbon free manufacturing of battery.
carbon-free manufacturing of EV battery is a very long achievable goal. It is the whole global world is working on it because you need to understand that the battery needs some elements. If you are the students of chemistry, there are 109 elements, I think, 109, 101. I'm not sure. I forgot. It's in a chemistry book. So these elements are in very specific locations in the world. Now, to get these elements, of course, you need power, you need energy, you need manpower, you need machinery, you need equipments to bring these elements. So I highly doubt. There's a lot of debate, by the way, going on. There's a lot of controversy going on for extracting these elements because they are mostly in the African part of the world, where there is child labor. Then the question comes of the controversy. I mean, you can go into a lot of debates. But yes, the carbon free is we are working on the carbon free. It is not achievable as of now. Carbon free world is what we are working for net zero 2050. So which is a part of it. So by that time, by 2050, I think the entire process will be carbon free.
Okay, thank you, sir. So there's another question regarding lithium-ion battery. It is asked that is it so that lithium-ion battery manufacturing is more polluting than the fossil fuels?
Sorry, can you ask me again?
The question is that is this so that the manufacturing process of lithium-ion battery is more polluting than the
Yes.
fossil fuels?
Yes, it's true. That's true. See, again, this is what I told you that the process and the debate, the controversy. If we go into this controversy, you can never reach anywhere. I mean, this is like a chicken and an egg fight. Which comes first? If I want to drive my electric car, I need a battery. The battery is extracted as an element from some part of the country. Now, if you go to the debate of how it is extracted, which country, what kind of labor, maybe it's a child labor, oh, it's blood diamond, or it's not blood diamond. So it's a long debate, it's a long controversy. We can go into it. But yes, the question is right. It's again, we are working towards a common goal. We as a society, people, OEMs, manufacturers, consultant like us, we are always debating on these factors. But we don't need to make it a controversy. We need to have a solution for the controversy.
ओके लीलेश, आपका क्वेश्चन बहुत अच्छा था और सर ने बताया कि ऐसा होता है कि लिथियम आयन बैटरी की मैन्युफैक्चरिंग प्रोसेस में काफ़ी पॉल्यूशन होता है, बट द पॉइंट इज़ दैट कि हम धीरे धीरे करके इम्प्रूव हो रहे हैं और डिस्कस करने को ऐसे बहुत सारे पॉइंट्स निकल जाएंगे जो कि नेगेटिव हुए हैं, बट ऐसा होता है कि इन द एंड वी आर इन द बेनिफिट साइड। और इसके सिर्फ पोल्यूटिंग फैक्टर्स ही नहीं हैं, हम सोशल फैक्टर्स देखें तो वो भी हैं, जैसे बैटरी जहाँ से जो मटेरियल जहाँ से बन रहा है वहाँ चाइल्ड लेबर फॉलो हो रही है क्या, सो एंड सो ही विशेस टू से दैट कि वी शुड फोकस ऑन द पॉजिटिव साइड एंड वी शुड गेट और फोकस ऑन द पॉइंट कि जहाँ पर चीज़ें पॉजिटिव हैं और लेस पोल्यूटिंग है, as we
Yeah,
have already discussed.
and also to add that it's not only that you need to think that to find a solution of the question that you asked. It's very easy for all of us to have this question and these kind of questions. I really appreciate that whoever asked this, because you see these questions encourages people like us to work on it. And at the end of the day, the whole global world is working on this question. And we are trying and finding the best possible solution. This is why the global EV, global net zero targets are kept 2050, some are 2060 to 2070. India has 2070 targets. You know why? Because India is one of the biggest, I'm so sorry to say, biggest polluters of the world. And the targets are 2070. Why? Because they know that it's very hard to achieve now. And the countries who has done 20 to 35, 20 to 2060, sorry, 20, 2030, 2025, like Canada, I said 2026, they see that they can do it, but India cannot do it. That's why 2070, they think and they assume it's an achievable target, which will put together the entire effort of your question to achieve that. So 2070, imagine, is a struggle, time, and required to achieve 20 targets of net zero.
सर को आपका क्वेश्चन बहुत पसंद आया एंड ही सेइंग दैट कि ऐसे क्वेश्चन से उनको मोटिवेशन मिलता है कि वो इन चीज़ों पे काम करें. So there is another question. It is asked that generally it is said that the life of battery is 3 years. So
Yes.
is the research is going to increase life of battery and reducing cost of battery, as the cost of battery includes indulges 40% of the cost of the vehicle itself.
Very good question. Whoever has asked, very good question. See, uh, electric vehicle battery is not 3 years warranty. First of all, electric vehicle battery uh, differs again. For example, the cars that we are selling, I'm selling it with 8 years. I'm selling it with 6 years warranty. Again, depending on the manufacturer, you're giving the warranty. Now, back in China, my manufacturer is selling the same vehicle battery for lifetime warranty. That's a confidence of the manufacturer. So you see the difference why he's selling it 6 and 8 here and he's selling it in China. Difference of the weather conditions, difference of the topography, difference of the geography, difference of the road infrastructure. Now, coming back to the investment cost, yes, a large data research is going on to put down the cost of electric vehicle battery. Why? The question is right. That the most expensive part of the electric vehicle is the battery. For example, somebody asked me that if I fail my battery or my battery get damaged in the vehicles that I'm selling, how much is the cost of the battery? I told him 70% of the car price. 70% of the car price. And it's a very rare case that your battery would go. I mean, we would really award that driver who would fail the battery because it means he's failing the confidence of the manufacturers and the sellers behind it. So I hope I answered the question.
So the another question, I think I also like this question. So he's talking about the uh, pollution and the waste collected from the dead lithium battery. He's talking about the end of life of the battery and then the waste management regarding the battery, the
Very
pollution
good.
caused after that.
Very good question. You see, again, if you look at the Microsoft, I think Bill Gates and Jeff Bezos of Amazon, they are working on this technology already. You see, only the smart people, we say why they're rich people because they're more smarter than all of us. The factors of the waste management that you asked through these questions are going to come in the future, and they already have a solution for it, and they're working on it. So these solutions are already there. For example, it's in English we say that somebody's garbage is one's treasure.
Treasure, exactly, sir.
Yeah. So they are
Another
working. Yeah, there's a solution on it, and there are people already working on it for the waste management factor of these.
another question is regarding leakage flow of current and electric vehicle. Is there a leakage current flowing in the electric vehicle?
There is nothing such as such. There is nothing. This is just a myth. Nothing like that. There is AC current. There is DC current. AC is alternating current. DC is direct current. And you have a onboard charger in the vehicle that convert the AC into DC for the car to have charge. There is nothing as such.
So there is no current flowing in when the power is not turned on, like the battery discharging automatically into resistive load or something like that.
No, I mean, or maybe I don't understand the question. Can you repeat again? Sorry.
So he means to say that since there is a power supply, there's a source, there's a battery in the vehicle, and there are
Yeah.
many circuits there.
Yeah.
So even if the key is not on, the power is not on, is it so that those circuits are having microampere currents in them due to battery? If the battery is
No.
providing any small amount of current?
No. No.
No.
If the vehicle is off and not using, no.
Mhm. Okay. तो KR creation ऐसा लीकेज करंट इलेक्ट्रिक व्हीकल में फ्लो नहीं होता है.
There
Ah,
is no
there,
leakage. There is nothing as such called leakage. Maybe he could not drive his question right. There is nothing called leakage. If there is a leakage, it means the car system has flaws.
okay. Um, what could be the major types of fault that a car electrical bus could face? What could be the major types of fault that a
Okay,
bus can have?
you need to treat electric vehicle bus as an electric car first. It's at the end of the day, it's an electric vehicle, right? So I personally believe that electric buses they need a vast amount of expensive amount of charging infrastructure because uh, the batteries are bigger in size than the electric vehicles. So in that case, sorry, I'm skipping my question. Can you repeat the question again?
Hold on a second, sir. I think we have missed the question. Types of faults that might occur in an electrical bus.
There is no types of fault can occur in the electric buses. I mean, it depends upon again the driving habits, how you're driving. You could have a skilled driver, you can have unskilled driver, and then driving electric vehicle is not just about driving. It's about a habit. I mean, if I am driving electric vehicle, talk to me because I'm driving it for about a year and a half. I cannot drive a diesel or engine car or fuel car. It's totally a different habit. It's a totally different scenario. So you need to have that habit of driving electric car. Yeah. So I doubt that there could be any faults.
Okay, so I think that we are done with the questions. Are there any more questions? We are closing the question answer session now. किसी और को कुछ पूछना है, हम questions लेना बंद करेंगे. Okay, so we are closing the question sessions. So I thank you so much, sir. I'm so much thankful to you, Mr. Adil Arshad, sir, that you gave us 2 hours of your busy schedule, and we have learned a lot from you. And I'm really, really, really thankful to the TTC and LRDC department that they had facilitated this program for students. And because of the department, TTC and LRDC, the students could interact with you, learn from you a lot. So I'm really, really thankful for that to them for organizing this session. And
Thank you. Thank you to Neha. Thank you to your team. And I wish you all the best and good luck for this beautiful work that you're doing. And together we can bring a lot of difference. So I'm there if I can make a difference from my side.
Thank you so much, sir. Thank you.
Thank you. Bye bye. Good night. Thank you.
Good night. Hey guys. तो सर ने लीव कर दिया है और आप बताओ कैसा रहा सेशन? आप सब लोग वाईके अग्रवाल सर को जॉइंट डायरेक्टर ऑफ टीटीसी एंड एलआरडीसी को याद से थैंक यू बोलें कि उन्होंने आपके लिए ये सेशंस रखवाए थे. पूरा प्रोग्राम ट्रस्ट टीवी अवेयरनेस ओथ का, जिसके अंदर आपने बहुत कुछ सीखा है. इट इज ऑल बिकॉज ऑफ हिम एंड द होल टीम ऑफ टीटीसी एंड एलआरडीसी. ये सिर्फ इन्हीं की वजह से हो रहा है कि आपको इतना कुछ सीखने को मिल रहा है इतने अच्छे अच्छे लोगों से. सो मेक श्योर कि आप अपने नोडल ऑफिसर को थैंक यू बोले एंड अग्रवाल सर को भी थैंक यू बोले. एंड मेक श्योर कि आप टीटीसी एंड एलआरडीसी डिपार्टमेंट को थैंक्स बोले, क्योंकि उनकी वजह से आपने ये सब कुछ सीखा है अभी तक. ओके ओके तो सर ने अपन को बेसिकली क्या है कि इलेक्ट्रिक बसेस के बारे में बताया था आज. पहले उन्होंने ये बताया कि टॉप 10 बसेस कौन से हैं ऑल ओवर इंडिया में, है ना, आई एम सॉरी ऑल ओवर वर्ल्ड में. तो टॉप 10 बसेस बताने के बाद उन्होंने अपन को ये बताया कि कौन कौन से मैन्युफैक्चरर्स हैं. फिर उन्होंने ये समझाया कि ऐसा क्यों है कि चाइना इज लीडिंग इन इट. चाइना क्यों लीड कर रहा है इसके अंदर इलेक्ट्रिक व्हीकल में, और यूएस या फिर दूसरी कंट्रीज क्यों नहीं लीड कर रही, है ना. फिर उन्होंने थोड़ा ये भी समझाया कि नेट प्राइस जो है वो चाइना की कम है बसेस पे, पर जो टेक्नोलॉजी है वो यूएस यूरोप की ज्यादा अच्छी है. फिर उसके बाद उन्होंने समझाया कि बैटरीज उसमें कितने कितने रेटिंग की लगती है. आपको ध्यान है अपन ने पावर ट्रेन कैलकुलेट करी थी तो उसके अंदर बैटरी देखी थी, मोटर लगाई थी पहले सारे फोर्सेस निकाल करके, मोटर के बाद अपन ने सारी एफिशिएंसी वगैरह कैलकुलेट करके और फिर बैटरी की रेटिंग डिजाइन की थी। तो आज उन्होंने जो एक स्लाइड बताई थी ना, उसमें सारा का सारा इलेक्ट्रिक बस में जो बैटरीज लगती है उनकी रेटिंग और मोटर की रेटिंग थी। ठीक है, उसके बाद उन्होंने चार्जिंग सिस्टम के बारे में बताया था अपन को कि हम किस किस चीज से चार्जिंग करते हैं। उसके अंदर अपन ने सारा पढ़ा हुआ है ना, एसी चार्जिंग, डीसी चार्जिंग, पावर की रेटिंग के हिसाब से अपनी जो चार्जिंग होती है वो। उसके बाद अपन ने ये देखा था कि जब आप गाड़ी को एयर कंडीशनिंग के साथ चला रहे हैं, तब हमारी जो गाड़ी की रेंज है वो कितनी कम ज़्यादा हो जाती है। एसी चलाते हुए चलाते हैं तो, और नॉर्मली चलाते हैं तो मौसम के हिसाब से हमारी गाड़ी की रेंज सेम बैटरी के साथ कितनी ज़्यादा ऊपर नीचे हो जाती है, अकॉर्डिंग टू आवर यूसेज। फिर उन्होंने इलेक्ट्रिक व्हीकल की बैटरी के फटने के बारे में बहुत सी चीज़ बताई कि ऐसा नहीं है कि मैन्युफैक्चरिंग डिफेक्ट ही है, हम उसको कैसे यूज़ कर रहे हैं, हम उस गाड़ी के साथ एक्चुअली कर क्या रहे हैं, वो बहुत बड़ा फैक्टर है। और जब आपने ये बोला कि हमने इलेक्ट्रिक व्हीकल की बैटरी फटने की बहुत सारी न्यूज़ देखी है, तो उन्होंने ये रिप्लाई किया था कि जब आप इस बात की तह तक जाएँगे तब आपको पता चलेगा कि इसमें मैन्युफैक्चरिंग डिफेक्ट नहीं था, उसमें एनवायरमेंटल प्रॉब्लम्स थी। वहाँ की जो स्थितियाँ हैं उसमें प्रॉब्लम थी, बैटरी मैन्युफैक्चरिंग में प्रॉब्लम नहीं थी। तो ही रिप्लाइड अबाउट दैट। उन्होंने जब आपने कार के पहिए के बारे में बात की थी, बस के पहिए के बारे में कि वो इतना नीचे क्यों होता है, तो ही रिप्लाइड दैट वो कंट्री टू कंट्री डिपेंड करता है, अपने यहाँ की रोड कंडीशन एटसेट्रा। बाहर वहाँ ओमन का उनका कहना है कि वहाँ ऐसा तो नहीं होता है। ठीक है, सही है। और कुछ कुछ क्वेश्चंस आपके रिपीटेड थे, वो तो अपने लेक्चर में कवर कर रखे हैं। अगर आप लेक्चर्स देख लोगे तो आपके डाउट्स क्लियर हो जाएंगे कि वो जनरेट नहीं कर सकते कि बैटरी से, और सो एंड सो फोर्थ। गाड़ी चल रही है तो उससे क्यों जनरेट नहीं कर सकते, वो रीजनरेशन में हम पढ़ चुके हैं। ठीक है, दिल्ली में है इलेक्ट्रिक बस, इंडिया में आ गई है। बहुत सारे लोग अब कन्वर्ट भी करने लगे हैं। ऐसा नहीं कि बहुत सारी देखने को मिल जाएगी, बट है, ऐसा नहीं है कि हमारे पास बिल्कुल भी नहीं है। वी आर ग्रोइंग। ठीक है, चलिए अटेंडेंस लेकर ऑन हो जाएगा, यू कैन फिल योर अटेंडेंस। बाय। आई होप कि आप सबको अच्छा लगा।